Welcome back, students. We'll be looking at section 3.2, terminology for graphing linear equations into variables. So let's start with graphing linear equations by plotting ordered pairs. A linear equation has an infinite number of ordered pairs as solutions. So find the ordered pair solutions by choosing different values for x or y and solving for the variable you didn't choose to get the other half of your ordered pair, which is what we did in the last section. They're just going to take it a step further and add to that process. So let's look at the first few examples. Find ordered pair solutions for the linear equation and plot them on the graph. So we're going to use this equation right here to solve all four of these boxes. So I'm going to write that equation in all four, just so we have that already done for when we start to solve. All right, looking at our first box, it says, what if we choose x equals 1? So I'm going to plug the 1 in for the x. Subtract that 1 from both sides. I get 0 plus 2y equals 6. I'm going to bring that up over here. 2y equals 6. Divide both sides by 2. And I end up with y equals 3. I'm going to fill in my blank there. Next one. What if we choose x equals 3? How will that change our coordinate? So I'm going to plug in 3 for x. Subtract 3 from both sides. And I get 4 right there. Bring this up. 2y equals 4. Divide by 2 on both sides, and I get y equals 2. Third one, what if we choose y equals negative 1? So this time instead of x, we're going to do y and solve for x. So x plus 2 times negative 1 equals 7. X plus 2 times a negative 1 is going to give us a negative 2. So I'm going to write x minus 2 equals 7. Add 2 to both sides. X plus 0 equals 9. So x equals 9. Put that in that blank. Square around all of our answers we found so far. All right, so our last one says, what if we choose y equals 0? So x plus 2 times 0 equals 7. So x plus 0 equals 7. So x equals 7. So we now have 4 coordinates that we can use for this next part. So connect the coordinates. The connected coordinates always form a straight line for a linear equation, okay? A straight line in a linear equation. And again, notice the word line in linear. It basically tells you what it is. Every point on the line represents a solution of the equation x plus 2y equals 7. The line extends infinitely in both directions. So we place arrows on each end of the line. So your line will look like this. Don't forget, if your line is not straight, then you need to look back at your work to find the error. So when you find these coordinates, you should form a straight line from these coordinates. If you don't end up with a straight line, something's wrong. So go back and check your work. And let's plot these that we found. 1, 3. So I'm going to go over 1 and then up 3. So that's our first coordinate right here. I'm going to label it 1, 3. All right. Our next one is 3, 2. So I'm going to change colors here. we're going to go over 3 and up 2. That's our 3, 2 coordinate. The third one is 9, -1. Let's see here. I got to go all the way over to 9 and then down to -1. So label that one. That's 9, -1. And our last one is 7, 0. So I'm going to go over to 7. Our y is 0, so I'm not going to go up anywhere. So our coordinate is actually right there on our x-axis. Move that. And now I'm going to label that one 7, 0, just so we can remember which one was which. Now I'm going to connect my coordinates, the dots that I placed. This is going to be a little bit tricky to do on here, but hopefully I can do this straight. I would recommend you use a ruler on your paper. So let's see if I can, hey, not too bad. I actually got that on there pretty nicely. It's not perfect, but it's pretty nice. All right, so you see we end up with a straight line. Graphing linear equations. Any value can be chosen to use for finding ordered pair solutions of a linear equation, but 0 and 1 are the two easiest values to use most of the time. They're going to be the simplest. Finding intercepts. The x-intercept crosses the x-axis of a graph at a number, 0. So for example, we have this one right here. Okay, so our example is the x value is 4. We went over 4, right? We went this direction 4, but we didn't go up or down. So our y is 0. The y portion of the coordinate is always 0 when we're talking about the x-intercept. It's where it crosses the x-axis. The next one is the y-intercept. It crosses the y-axis of the graph at 0, number, right here. So in this example, we have 0, 3. Our y value is 3. So the portion of the x portion of the coordinate is always 0 in the y-intercept. Because we're not going left or right, we're only going up or down, which means we're going to cross that y-axis. Now let's use this information to help us find our x and our y intercepts to form a linear equation in standard form. Find the x and y intercepts for the following linear equation in standard form. So the first thing I'm going to do is I'm going to use y equals 0 to find my x-intercept. So I'm going to plug in 0 for my y. So 5. Actually, my x-intercept was blue, so I'm going to switch to blue. Let me do that, just so we have consistency here. All right, so I'm going to say 5x plus 2 times 0 equals 10. 5x plus 0 equals 10, so 5x equals 10. Divide both sides by 5, and I get x equals 2. So my x-intercept is at 2, 0. I'm going to go ahead and plot that. I'm going to go over to 2, 0, and plot. That's my x-intercept. It's actually on my x-axis. In our next one, we're going to find our y-intercept by making our x 0. So 5 times 0 plus 2y equals 10. 0 plus 2y equals 10. So 2y equals 10. We're going to divide by 2, divide by 2. So y equals 5. So our y-intercept, we're not going to go right or left because our x is 0, but we are going to go up to 5. And that's our y-intercept. Now, we could draw our straight line from that, but we're going to do one more coordinate just to double check ourselves. Let's just choose 1 if x equals 1. So 5 times 1 plus 2y equals 10. 5 plus 2y equals 10. I'm going to subtract 5 from both sides. I get 2y equals, or excuse me, 0 plus 2y equals 5. Bring it up over here and finish it. 2y equals 5. Divide by 2, divide by 2, so I get y equals 5 halves. You say, well, that's a fraction. How do I plot that? Well, if I turn it into a mixed number, then it's a little bit easier. So 5 divided by 2. 2 goes into 5 2 whole times, and I have 1 left over. So I have 2 and 1/2, or that's the same as 2.5, remember? So I can plot 2.5. So I'm going to go over 1 and then up to 2.5. So it's about right here, okay? Now I can draw my straight line. Let's see if I can do this here. Yeah, not too bad. And we actually have our line graph just by finding our x and y intercepts and one extra coordinate. All right, so don't forget to connect the coordinates to form a straight line. Don't forget that part. Next section, graphing horizontal and vertical lines. The horizontal line equation is y equals a number, okay? The horizontal lines go infinitely from left, let me change that to a color so we can see it better. From left to right, okay? So horizontal lines are like this. The vertical line is x equals a number. That's the equation for it. Vertical lines go infinitely up and down. All right, so I have images here to kind of help you. The horizontal line is like the horizon, right, in this image. Goes left to right. The vertical line is like this skyscraper. It's vertical, up and down. The horizontal line does not have an x-intercept, okay? It doesn't cross the x-axis. It only crosses the y-axis, all right? The vertical line does not have a y-intercept. It does not cross the y-axis. It only crosses the x-axis. So that's important to remember. One other point is the point right here and the point right here. If you see an equation that says y equals 0, this is the only time that a horizontal line will actually touch the x-axis. It's because it is the x-axis. So if y is 0, your x-axis is your line. That's the only time it'll actually touch it. In x equals 0, that is the only time that your vertical line will touch the y-axis, because it is the y-axis if x is 0. And when you graph, you'll see what I mean there. But otherwise, they should not intersect if it's one of these lines. All right, so an example. We have a horizontal line here. We have y equals 4. And you'll notice right here, all of the y's are 4. But let's plug in some x values. I just have to pick some random plots along this line, and there'll be solutions. So I'm going to pick -3. So that's -3, 4. Well, what if I pick 0 for x? I'm right here. So that's 0, 4. And if I pick +3, that is also a 4y. So we have 3, 4. Well, look at the vertical line, x equals -3. Our vertical line is crossing the x-axis at -3. So my x value is always -3 here. But what about my y value? I can pick random locations along here to get a y value that would be a solution. I'm going to pick, let's pick the same numbers. -3. So that would be -3, -3. What if my y was 0? I would be here. And if my y was 3, I would be here. So this is just to show you why in the horizontal line, all your y's would be the same. And in the vertical line, why all your x's would be the same. All right, guys, let's look at our verse. Great is our Lord and mighty in power. His understanding has no limit. Psalm 147:5. Hope you're having a great day. I'll see you in the next video. Bye, guys.